In this video, we'll be solving systems of equations algebraically, more specifically by substitution and elimination. Okay, a systems of equations is a set of two or more equations that uses the same variables. A solution of that set is a set of values for the variables that make all the equations true. For example, -6 is the solution for this systems of equations. And to prove it, what you would do is you would actually plug in -6 into your x and your y value, because this is your x, this is your y value. And if you were to solve, this statement should be true. 2 times -6 is -12. -3 times -6 is a positive 18. -12 plus 18 is 6, which is exactly what we were supposed to get. It also works in the other equation as well. So if I was to plug in -6 into this x value and -6 into this y value, we want to know, does it give us -12? Well, -6 and -6 is -12, which means yes, that statement is true. So now let's actually solve by substitution. So substitution is exactly what it means. You are substituting an expression in for a variable. So for example, you have an expression 8y minus 12 is equal to x. It represents x. So if you were to take this entire expression and you were to substitute it into that x value, you'll be able to solve the equation. So this equation, instead of saying x plus 12y, I'm actually going to input what x represents, 8y minus 12, into that x value, and now I'm going to rewrite the rest of the equation. And at this point, we now have a multi-step equation that we can solve. 8y and 12y are on the same side of the equals, so they need to be combined into 20y. Minus 12 equals 68. To solve, I'm going to add 12 to both sides. I will get 20y equals 80. And now the last step is to divide by 20. And so y equals 4. We have now found one part of our solution. We now need to go back and find x. Now, we can go back to either equation. It does not matter. I'm going to choose the bottom equation. X equals 8y minus 12. But we just determined that y is the number 4. So 8 times 4 is 32, and 32 minus 12 is 20. So now that we've found both our x and y, we can write our answer in the coordinate point, which is the coordinate point 20, 4. And that is the solution to that answer. You can actually check it by plugging 20 and 4 back into both equations to make sure it did work. Also, if you were to graph these equations using the y equals mx plus b, those two lines that are created will actually cross at this point 24. Here's another one for substitution, so let's try this one. Y is equal to 2x minus 7. Therefore, I'm going to substitute this expression in for y. So instead of saying 4x plus 3y equals 4, I'm going to plug in what y is, 2x minus 7. And now we're in an equation that has only one variable that we can solve. I'm going to draw a line down the middle, and I'm going to solve it. So I will get 4x plus, just kidding, not 3. We'll get 4x plus 6x minus 21 equals 4, because you have to distribute the 3. 4x and 6x were on the same side, so they need to be simplified and just combined. So to solve for x, I'm going to add 21 to both sides first. I will get 10x equals 25. And now the last step is to divide by 10, and x equals 2.5. Now that we found x, we can go back and find y. Y equals 2x minus 7. But we've now determined that x is 2.5, so I'm going to plug it in. 2 times 2.5 is 5. 5 minus 7 is -2. So y equals -2. So our coordinate point is 2.5, -2. Next, elimination. Now, elimination is, again, exactly what it says. Substitution meant that you were substituting an expression in. Elimination means you are actually eliminating one of the variables. So in this case, we have 2m plus 3 equals 12, and 5m minus n equals 13. We want to eliminate. Now, there's a couple of things you need to understand for elimination. In order to eliminate a variable, you have to have the same coefficient in front, which we've talked about in the past. The coefficient is the number in front of the variable. So in this case, 3 is the coefficient. So the variable will have to have the same coefficients in front, and they will have to have opposite signs in order for them to cancel each other out. So I noticed that there's a 3n at the top, and there's a negative n at the bottom. If I was to multiply this bottom equation by 3, that will give me a negative 3n. And this negative 3n, along with this positive 3n, will eliminate each other. So I am going to multiply the bottom equation by 3. It is allowed as long as you are multiplying the entire equation by that number, not just the n, but by everything. So I'm going to rewrite the top equation because I'm not changing it at all. The bottom equation, I'm now going to multiply by 3. 3 times 5 is 15m. 3 times negative n is a negative 3n. And 13 times 3 is 39. Now that I have found a variable that has the same coefficients and opposite signs, I can go ahead and eliminate them. If I was to add these two equations together, 3n and a negative 3n give me 0n, which cancels. 2n and 15 give me 17m, and 39 and 12 give me 51. I now have a single variable that I can solve. So we are going to do that by dividing by 17, and m equals 3. That is one of our variables. We now need to plug m back into one of our equations in order to find the other variable. So I'm going to take the top equation. It doesn't matter. You can do either equation. I'm going to take the top equation, and I'm going to substitute the 3 in for m. So instead of it being 2m, it's going to be 2 times 3. 2 times 3 is 6, plus 3n equals 12. To solve for n, I'm going to subtract 6 on both sides, and then I'll get 3n equals 6. I now can divide by 3, and so n equals 2. And we have now found our solution to the system of equations. M equals 3 and n equals 2. So let's do one more. In this case, it's a little bit different because we don't have an easy way in order to get a variable that would have the same coefficient. This 5 and 2 have nothing in common. This 2 and 3 have nothing in common. I do notice that the y's at least have opposite signs. So I'm going to use the y's to do my elimination. I have a negative 2 and a positive 3. So I need to figure out what number can I make a 2 and 3 become. Like basically, what is 2 and 3? What is the least common multiple, to go back to 8th grade, your LCM, what is the least common multiple between 2 and 3? It is 6. So if I want to make both of these coefficients become a 6y. So in order to do that, I'm going to multiply the top equation by 3, because 2 times 3 will get me the 6. And I'm going to multiply the bottom equation by 2, again, because 3 times 2 will get me 6. So let's go ahead and begin. If I multiply the top equation by 3, I will get 15x minus 6y equals a negative 57. Sorry, took me a minute. The bottom equation, if I was to multiply by 2, I will get 4x plus 6y equals 0. I now have a variable that has opposite signs and the same coefficient that will now cancel each other. They will eliminate each other when adding. So they will eliminate. 15 and 4 give me 19x equals negative 57. So if you divide both sides by 19, x will give you a negative 3. Now that is my x coordinate. Now I need to plug or substitute that back into one of these equations to find the y coordinate. So I'm going to do the bottom equation. Again, it does not matter which one you do. So I'm going to take the bottom equation, which is 2x plus 3y equals 0, and I'm going to substitute my x value. 2 times negative 3 is negative 6. Now to solve, I'm going to add 6 to both sides. 3y equals 6, so y equals 2. And since it's an x and a y, I'm going to write it as a coordinate point, which would be negative 3, 2, as my solution. Okay, there are two different types of special cases when it comes to systems of equations. You can have a dependent and you can have an inconsistent solution, and I'm going to show you one of each. So in a dependent, I'm going to show you what's going to happen. So I need to eliminate one of these variables. X and 4, I can eliminate the X, I can eliminate the Y, doesn't matter, but I'm going to have an opposite sign to do that. So if I multiply the top equation by a -4, then the -4x will eliminate with a positive 4x. So -4 times x gives me a -4x. -4 times -3 gives me a positive 12y. And -4 times 2 gives me a -8. On bottom, I am not changing anything because I didn't have to. Now, when you add these together, the x's eliminate each other, which is great, leaving you 0. However, something interesting happens. The 12y and -12y also cancel, leaving you a 0 on the left-hand side because everything canceled. And what's also interesting is -8 and a positive 8 also eliminate each other, giving you 0. Will 0 always equal 0? Yes, always, no matter what. In this case, this is actually considered a dependent solution, meaning any value that you plug into x and plug into y will actually work. These basically are the same lines. The bottom equation just happens to be a multiple of the top equation. On the other hand, you can have something that is called an inconsistent solution, which means you actually will get something that is not possible. So in this case, I have a -3 and I have a 6. Well, I can manipulate the top equation to get something to eliminate. If I multiply the top equation by a 2, -3 times 2 will give me a -6, which will allow me to eliminate this positive 6. So I will get a -6x on top, 2 times y is 2y, and then 2 times 4 is 8. On bottom, I will get I'm just going to rewrite the whole thing. What happens, unfortunately, here is when you add, the x's do eliminate each other. However, again, just like over here, the y's also cancel. 2 and a -2 leave you also with a 0. However, on the right-hand side, 8 and 5 give you 13. Can 0 ever equal 13? No, never. No matter what x and y you attempt to plug in, you can never get these two lines basically to cross. If you were to graph these two lines, they would actually be parallel lines that never cross. So that is why the answer to this equation would be either inconsistent or no solution.